Hello friends, welcome back. Today we will discuss about inventory control. So in inventory control, we will discuss about four different models in the inventory control. So let's start inventory control. First, we will introduce the first model. So prior to that, we will discuss about some introductory about the inventory control. So in introduction, we have few terms related to cost, and first cost we have is ordering cost. So we can say that order cost. So order cost, what will say that order cost? So whatever the rent, salaries, traveling allowance, stationery, telephone bill, electricity bill, all these type of bill occurred with the purchase department. So whatever the bill extra cost occurred with the purchase department is nothing but the ordering cost or order cost. So if you have annual demand of A and you are so let us say 1000 quantity. If you have annual demand of 1000 quantity, and if you have monthly consumption of 100 quantity, then you have to place 10 orders. So for satisfying the 1000 of annual demand, you have to place 1000 10 orders. So for those 10 orders, you have to place 10 orders. So you have to pay some extra cost like telephonic cost, stationery bill. If some person is going to purchase that particular quantity, then you have to pay traveling allowance for that particular customer or for that particular employee. So that particular cost will also come in this category, and that will be the ordering cost. So that will also come in the ordering cost. So we have different costs which is associated with the ordering cost, and those costs can be like rent, like salaries, travel allowance, stationery, telephonic bill, electricity bill. All these costs of the purchase department will come in the category of ordering cost. So if you have annual demand of A and the ordering quantity is Q, annual demand is A and ordering quantity is Q, and cost per order, this is the S, and we will say that this is the cost per order. Cost per order is S. Then total ordering cost will be A by Q into S. Let us say if we have annual demand of 1000 quantity, and we are placing order of lots of 100 quantity, then we have to place 10 orders, and for if S is the ordering cost per order, then 10S will be the total ordering cost. So we have to pay 10S. If it is S is let us say 3 rupees or 2 rupees, then we have to pay 20 rupees or 30 rupees of ordering cost for ordering the for placing the orders. So we have discussed about the ordering cost. Next we will talk about the inventory carrying cost. So variables in the ordering cost are: A is the annual demand, S is the cost per order, and Q is the order quantity. So we have discussed Q is the order quantity. Next we will talk about the inventory carrying cost. So we will discuss about the inventory carrying cost. What is inventory carrying? So we will discuss about the inventory carrying cost. In inventory carrying cost, we have a different cost. Whatever the cost associated with the store department or store, that will say that is the inventory carrying cost. So whatever the cost occurred in the store section, that will come in the category of inventory carrying cost. So let us say if you have rent, salaries, or traveling allowance of the employee associated with the store section, that cost will come in the category of inventory carrying cost. So it may be of a stationery bill, telephonic bill, or traveling allowance, or electricity bill associated with that particular store section, that will say that is the inventory carrying cost. So if we have initial inventory, if we are placing the order, if we are receiving the quantity in the size of Q, so if we have initial quantity received is quantity Q, finally we will consume after the time, so final inventory will be 0. So average inventory will be Q plus 0 by 2, and if CI is the inventory carrying cost, then total inventory cost will be Q by 2 into CI. So average inventory carrying cost, that will be Q by 2 into CI, where Q is the lot size or quantity we are going to order, and that will be initially Q and finally it will be 0. So finally total will be, or you can say average will be Q plus 0 by 2, and CI will be the inventory carrying cost per quantity. So total inventory carrying cost, or we will say that average inventory carrying cost. So we can say that average inventory carrying cost will be Q by 2 into Ci. That will be the value of average inventory carrying cost. So we can find inventory carrying cost. We can also we have talk about the ordering cost, or we can say that order cost. So we have discussed two different type of cost. One is the inventory carrying cost, and another is the ordering cost. So sometimes what will happen in the given problem, you might have find that is this inventory carrying cost will be given as the I, and it is the percentage of inventory carrying cost, and also C, which is the cost per unit. So total inventory carrying cost we will find inventory carrying cost per quantity, we will find that C into I. So an average inventory carrying cost we will find by multiplying with the term Q by 2, where Q is the ordering quantity. So we have discussed about the ordering cost and inventory carrying cost. Next we will discuss about the. So let us discuss about this particular plot. So very interesting plot. This is very interesting plot. So this is the plot between quantity, ordering quantity, and the time. With the time, what will happen? So initially, what will happen? You are receiving the order, and that order will be in the quantity of Q. So initially, you have order, and when that is the quantity of Q. With the time, what will happen? You will consume this quantity. So after consuming this one quantity, there will be. If you will consume this quantity, what will happen? You have after a significant time, after your consumption time, it will be 0. So when that quantity will be 0, again you are receiving a fresh order, and that quantity will be Q. Again with the time you are consuming it, and it will be coming at 0. So when again it will become 0, again you are getting a fresh order, and that order will be Q. So in a particular time period, and we will say in a particular consumption period, we have initial inventory 0 Q and final inventory 0. So average inventory will be Q plus 0 by 2. So this particular plot is very interesting plot. We will discuss similar type of plot in different models. So this is nothing but plot between order quantity Q and time. So the time, consumption time, you can say, and the period you are going to do analysis like that. So we have discussed about the inventory carrying cost, and inventory carrying cost and ordering cost. Next we will talk about the ordering cost, or next we will talk about the economic order quantity. So what is economic order quantity? We will discuss over here. So what is happening is there. So we have two costs. So in the very one is the ordering cost, and another is average inventory carrying cost, or we can say that this is the inventory carrying cost. So we have two costs. One is ordering cost, and another is the inventory carrying cost. So we have two different costs. One is the ordering cost, and another is the inventory carrying cost. So that together we will say that is the total variable cost. So total variable cost, we can write that A by Q into S plus Q by 2 into Ci. So in this particular term, we have two different costs. One is ordering cost, and another is the average inventory carrying cost. So we have two different costs. One is the ordering cost and order cost, and another is the average inventory carrying cost. So what is happening here over here is that, so this particular total variable cost is decreasing with the increase in the lot size, or you can say order quantity. So we have Q as order quantity. So if you increase the order quantity, this total variable cost is decreased, because ordering cost will decrease. On the other side, if you increase the order quantity, what will happening is this total variable cost is increasing. Why it is increasing? Because average inventory carrying cost is increasing. So if you order more, what you have to do is you have to carry that particular order, because it will take more time to consume. So you have to carry the orders, or you have to carry the quantity for longer period. So what will happen? There will be a more inventory carrying cost. So you have to pay more inventory carrying cost. So what we will do, what is happening over here is that one quantity is reducing, and one is increasing, and another is reducing, or you can say one is reducing and another is increasing. So if you increase the order quantity, this ordering cost will increase. On the other side, inventory carrying cost will decrease. So what we are doing, we are going to find some optimal value of order quantity, so that we can have a optimal total variable cost. So for that, what we will do, we are seeing over here that this particular variable cost is a function of quantity Q. So if we say total variable cost, so we have total variable cost which is a function of Q. So for finding the minimum value of total variable cost, what we'll do, we'll differentiate the total variable cost as a function of Q and we will equate to 0. So we will, for finding the minimum value of total variable cost, what we'll do, we will differentiate the total variable cost with respect to order quantity Q and we'll equate to 0. And we'll go for finding the value of Q. Assuming that there will be some constant, and those constants are, we have constant demand. We are assuming over that the demand is constant. Inventory carrying cost is also constant, means C and I, value of CI is constant. There is no any lead time. So lead time, the value of lead time is 0. We will say that lead time is the, let me know what is the lead time. Lead time means if you are placing order today and after 4 days if you are receiving the order, so that particular 4 days is nothing but the lead time. So that is the lead time. So we are assuming over here that annual demand inventory carrying cost is constant and there is no any shortage. So if we have a demand, we will fulfill that demand. There is no any shortage of the quantity and also there is no any lead time. So assuming these 4 assumptions, what we'll do, we'll find the minimum value of total variable cost. So we can find the minimum value of total variable cost by differentiating total variable cost as a function of Q and equating to 0. So after solving this, we have the total variable cost as A by Q into S plus Q by 2 into Ci. So if we differentiate this, we will find the differentiation of 1 by Q is minus 1 by Q square and differentiation of Q is 1 over here. So if we simplify this, we will find the value of Q, and Q we are writing over is as Q star, and this Q star will be 2 times AS by Ci. This particular Q star is known as economic order quantity. So we have obtained an expression for economic order quantity. This particular relation, above relation formula, we will say that Wilson's formula for finding the economic order quantity. So this is the Wilson formula for finding the economic order quantities, that what is the value of economic order quantity. So we can find the value of total variable cost at economic order quantity, and that particular cost will be A by Q into S plus Q by 2 into Ci. If we will replace the value of Q star as 2S by Ci, so if we replace the value of this as 2S by Ci, we will simplify this. So if we replace this by 2S by Ci and we will simplify it, so after simplification we will get that the total variable cost will be 2As into Ci. So it is very simple to remember. Q star is nothing but 2 times 2 ASIC, 2 times ASIC. So where As is in the numerator and Ci is in the denominator. But in the total variable cost, it is 2 times ASIC and this is completely in the same. So there is no any proportion and there is no this fraction symbol. So it is very easy to remember. Economic order quantity, that is 2S by Ci, and total variable cost at economic order quantity will be 2AS Ci. So here it is product of 2s and into Ci, and it is the fraction of 2s into Ci in the square root, and there is also a square root. So we can find the value of total variable cost as well as economic order quantity by using this formula, and we can also find the total annual cost. So this is the total cost and that is the total annual cost. This means what is the cost going to be occurred in the annual. So for that particular N1 and A, so we can find that annual cost as A into C plus TVC, and that TVC will be A by Q into S plus Q by 2 into C. So total annual cost at any particular quantity Q will be A into C plus Q by A by Q into S plus Q by 2 into C, where A into C is the fixed cost, this is the ordering cost, and this particular value is the inventory carrying cost. So this particular ordering annual cost, total annual cost, is nothing but that ordering quantity Q. So we can also find the value of total annual cost at particular given at particular quantity and at optimal quantity, and that quantity will be Q star. So we can find the total annual cost at Q star, and that Q star the total annual cost will be A into C plus 2 times A into C, A into S into C I. So we can find total annual cost by using this formula or by this formula. We have to remember both the formula, because sometimes what happening in the question, they will give you quantity as a function of something or some constant as a function of quantity. So it is better to remember both the formula, total annual cost at particular quantity Q and also at some quantity at optimum quantity, or you can say at economic order quantity Q star. Now we will go for solving some problems. We will discuss some problem. So we have one question on the basis of this model we have discussed of the inventory control. So in the question, a company purchases 200 quantities. So one company is there which is purchases 200 quantities. 2000 quantity. So there is an annual demand of 2000 quantity. So A will be 2000 quantity of a particular items of some particular item per year at a unit cost of rupees 20. So the unit cost of that particular item is nothing but 20. So C will be 20. Ordering cost per order is rupees 50. So by the unit we will discuss, we can identify what is the variables we have given. So here you can see that cost per order. So this is nothing but ordering cost. So S, this is S. And the inventory carrying cost is 25%. So it is the value of I, and that I is nothing but is a fraction of percentage of the unit cost. So inventory carrying cost is 25%, means rupees 5. 5 rupees 5 will be 25% of rupees 20, that will be 5. So rupees 5 will be inventory carrying costs. Next we have to find the optimal order quantity. So we have to find Q star and minimum total cost including purchase cost. So we have to find total annual cost, and it is saying that we have to find minimum value. So minimum will be at Q star. So we have to find Q star, and also we have to find total annual cost at Q star. Very easy question. We can find this particular solution. We can solve this particular question by very simple. So second part of this question is there. So if a 3% of discount is offered by the supplier, so supplier what is doing is it is giving some attraction as a terms of discount. So we'll see that this particular discount is favorable or not. We have to accept this discount or we have to reject this discount. So if the value of discount, if the total annual cost after this particular discount is coming more than this minimum total annual cost, then we will reject the discount. And if it is coming lesser than this particular total annual cost or this particular minimum annual cost, we will accept that particular discount. So we are going to solve this particular question. So whatever the terms we have given, we will mention over here. So we have annual demand of 2000 quantity, unit cost is rupees 20. This is in the rupees, this is in the rupees per order. So ordering cost is rupees 50 and this is per order. Inventory carrying cost is 25% of the unit cost, and that CI will be 25% of 20, and that will be rupees 5. So we have some parameters given. We will find the EOQ, and EOQ we can calculate by 2S into CI. 2A is the 2000, S is the rupees 50 per order, and this is per order. So we have rupees 50 per order. Inventory carrying cost is rupees 20 into 0.24 and 25, and that will be rupees 5. So we can put the values and we will find that there is a economic order quantity of 200 units. So for this 2000 quantity, if you are placing the order in the lots of 200 units, means number of orders will be how much? A by Q star, and that will be 2000 by 200, and so this will be 10. So number of orders will be 10. Number of orders will be 10. So we can find the total annual cost for economic order quantity, and we can find this particular total annual cost is EOQ at 2S AC plus 2S CI, and we have AC as 200, A is 2000, C is 20, and these values we have given. So after solving we will find that the total annual cost at economic order quantity is 41,000. So this is the minimum total annual cost. So after getting discount, so we'll see that what will be the value of total annual cost. So based on the discount, we'll find that what will be the value of total annual cost, and after that we'll compare the two costs, and we'll see if it is minimum after discount, we'll accept the discount, and if it is not, then we'll reject the discount. So it is saying that there is a 3% discount if you are ordering in a lot size of 1000 and more. So if you are placing the order, instead of having 200 quantity, if you are placing the order in a lots of 1000 and more, so we are placing the order in the lot size of 1000 quantity. So there is a offer, there is a discount of 3%. So this 3% discount will be on the unit cost. So your cost will be 3%, means 0.97% of 3C. So we have to pay, we don't have to pay rupees 20, we have to pay 97% of rupees 20. So we will find the cost after discount, and we will compare. So this is the minimum total cost we have to find. So we will find the total annual cost after the discount. We can find the total annual cost after discount by subtracting by placing the C in as a multiplier of 0.97%. So we can find here the value of R is 3%. So 1 minus 0.3 means this is 0.97. So 97% of C. So wherever the C terms, we will place this particular discount term. So this discount term will come over there. So annual demand we have 2000 quantity, C we have 20 rupees, and discount we have 3%. So this is 3 by 100. This term will remain as it is. There is no any change in this particular term. So third term will change. This term will remain as it is, and third term will change, and the change will be in the unit cost. So this is the change in the unit cost. So after solving this particular value, we will see that the value of total annual cost after discount is 41,325. So if you solve this particular term, you will get 41,325. But the minimum cost is 40,000. So minimum cost is 41,000. We have seen that minimum cost is 41,000. So we have seen over there that the minimum cost is 41,000. So we can see that, we can compare that the total cost after the discount is higher than the minimum cost. So what we will say that we will reject the discount. So we will reject the idea of discount. Total cost with the discount price is more than total annual cost at economic order quantity. So we will reject the offer and will not accept the discount. We have another one question in the similar way. So we have to find EOQ, economic order quantity, we have to find Q star, we have to find, then we have to find the number of orders. So number of orders will be A by Q star, and we have to find with the policy of ordering every month. Instead of placing the order in a lot size of Q star, if we are placing the order every month with them. So we will see what would be the annual cost as a percentage of the cost at EOQ. So total annual cost with monthly will be as a percentage of total annual cost of Q star into 100. So we will find the value of this. So we have to find these three terms: Q star, A by Q star, and total annual cost monthly by total annual cost in the EOQ into 100. So we will find these values. So we have given annual demand is A, and that is 1000 quantity. Order cost means that is S, cost per order. Holding cost is 10% of inventory carrying cost, and that is unit cost is 50. So inventory carrying cost CI will be rupees 50. So CI will be have 50. So I is 10%. So CI will be 50 rupees 50. That will be the inventory carrying cost. So we have annual demand of 1000 quantity. We have annual demand. C is the unit cost, and that cost we have given is rupees 500. Next cost, that is the order cost, and that is the rupees 40 per order. Inventory carrying cost, which is the percentage of unit cost, and that is the 10%. Next we will find, on the basis of given parameters, we will find the value of Q star, and that will be the 2S into CI. 2 into 1000 into S is the 40, C is the C value of C is 500, and I will be 01. So we'll solve this, and we can see that the economic order quantity is 40 units. So if you order in lot size of 40 orders, then we have economic order quantity, we have minimum total variable cost. We can find the number of orders, and number of orders will be annual demand by Q star, because there is a demand of 1000 and Q star is 40, so we have 1000 by 40, and that will come with as 25. So we have number of orders as 25. So this is the answer of B, part B. Next part we have to find the total annual cost by comparison of total annual cost if we are placing the order monthly. So we will place the order monthly, the number of orders will be 1000 by 12. So this will be the number of orders. So number of orders will be 1000 by number of orders will be 1000 by 12. So we'll find for ordering every month. So if you're ordering every month, so the number of or you can say instead of number of orders will be 12. It is nothing but number of quantity, not orders, number of quantity. Quantity will be 1000 by 12. This is not order. Since we are placing order every month, so number of orders will be 12. So number of orders will be 12. So and number of quantity will be Q will be 1000 by 12. So that Q will be 1012. So total annual cost at Q will be A into C, A by Q into S, and Q by 2 into CL. So we'll find the total annual cost at Q, and we'll also find total annual cost at Q star. So A and C we have known. A is 1000, C is we have given 500. So and A by Q will be 1000 by 12. So it is C is 500, A by Q will be this value. So if you solve this, we will find that total annual cost will be at this particular quantity, this particular order quantity will be 5,02,563. So now we'll see that total annual cost at economic order quantity. So we have economic order quantity, and we have ordering size is 40. So we can find the total annual cost at EOQ, that will be 2 A into S, A into C plus 2 times A into S CI. If we'll place the values of constants, so we'll find that the total annual cost at Q star will be 5,02,000. So if you are ordering per month, you have total annual cost. So it is better to order at EOQ. So we can place the order at EOQ. You will see this how much percentage there is a variation in total annual cost with respect to total annual cost at EOQ, at economic order quantity, and we can see that there is a variation of 100.11, means 0.11% there is a change in the if you are placing the order every month. So it is better to go for ordering at EOQ. Always it is better to place order at economic order quantity. So we have discussed economic order quantity, total variable cost, annual cost. We have calculated number of orders, also those parameters we have discussed. So we have discussed first module of economic order of inventory control. Next, in the next lecture, we'll discuss about the second model of inventory control, and that particular model is simultaneous production consumption model. So we'll discuss this particular model in the next lecture. Thank you so much for attending the class, attending the lecture. See you in the next lecture. Thank you so much.